Hello everyone, hope you're doing fine. My name is Mahmoud Ramdane. I am an architect based in Morocco, and I'm also a computational designer with a degree from the IAC Institute of Advanced Architecture of Catalonia. I'm having a very nostalgic moment right now, and so this is going to be a storytelling time. I was studying in the architectural school, I think 5 years ago, when I decided at one point that I'm gonna start using Grasshopper. I used to work with SketchUp at the moment, and they had no clue how to 3D model with Rhino. All I knew was some little snippets, some little pieces of code I got from here and there, from YouTube tutorials and so on. And so it did work actually. I managed to create something basically, which was a double skin system. So yeah, basically this is the project, and it was a competition, and that unfortunately we didn't win, but still it was supposed to be some sort of a smart library with smart components and so on. And so what we did is, we created form using Rhino. At that point, all I knew about Rhino were Boolean operations, and also being inspired by this guy, Stephen Hall, and the way he bakes and makes his architecture, always designing very graphical, hardcore elements on his facades as statements. And what I like also about his buildings is that he uses a lot of spheres. And I think that I've heard in one of his interviews that he spoke about some book he liked, which is by a certain philosopher called Peter Sloterdijk, I guess, if I pronounced it right. And the book is called Bubbles, where he speaks about being in this universe as intersections and meetings of many spheres, and each sphere has a center. And probably he alluded that societies are actually spheres on their own, and they have their actual centrality, and so everything converges. And he speaks of bubbles, so it's the smaller realm, and the bigger realm, I guess, was what he called the planets, I guess, something like this. And the larger, the broader picture, when we zoom out, we have the foam, when we have multiple planets and small bubbles, etc. Very interesting take that Stephen Hall actually uses in creating his own architecture. And so at that point, all I knew in Rhino was actually to make Boolean operations. So speaking of this project, actually what we did have was basically add with a volume. So we left some part of the terrain as a plaza, and then we decided that everything had to have some sort of relationship using spheres that intersect this overall volume. And I wanted that the facade actually reflects the skyline of the environment. So basically just scaling the bubbles so they would intersect, and the intersection would create this central zone, etc. And then I would create the entrance, and then many things also. And the second part was the double skin. So basically what I did for this project is that I made the first volume. I totally forgot how to use SketchUp. I made the first volume on Rhino, and because I didn't know how to use Rhino, I had to transfer my geometry to SketchUp in order to plug in my little components and families, and what do we call them, 3D objects. And so you can see here that I have a full project. This was, we used to do hardcore stuff back at the school days. We didn't sleep for this one. Anyways, this is not why I am here today. Actually, I'm here because, I'm making this video because I'm a little bit nostalgic about the early days when I started discovering Grasshopper and Rhino. And for a long time, while being a student, I only thought Rhinoceros was a software for modeling and Grasshopper is a software for crazy shapes and facade systems, etc. But as soon as I started working on my own stuff, I figured that no, that's not it. It could be something else. And it turns out that Grasshopper was so good at form finding. These types of diagrams. Actually, these were the steps that I used to actually think about my project. So I would like to, in this whole channel, I would like to teach Rhinoceros and Grasshopper, especially the Grasshopper part, as a computational mindset. So I would not teach you how to use the software because that's basically just learning some components and how they react to each other. But mostly what are the possibilities that we could do with it, and also a new way of thinking form, of thinking space, of thinking architecture using directives, right? And yeah, so let's get to it. That was a lot of storytelling for today. So what I did basically is that I created this simple box. I'm just scaling it so it has some sort of a regular form. I have no clue how much is the height, so I would say the height is 24. That's too much, I guess. That's fair. And the length, let's say it's 35 by 35. Just using the command scale one direction. I'm gonna zoom the selection by using ZS, which is the shortcut for zoom selection, and then scale one direction again. Maybe I would want 15 meters high building. So yeah, how can I use Grasshopper in this case? So I would like to create a joystick. What do I mean by joystick? I would want to create some sort of a video game here. So I would start creating my spheres, right? And as I create those spheres, I want to see how they react once we make a Boolean difference and what type of space do they leave to us. So I just launched the command Boolean difference. They're asking me what are the Boolean surfaces to subtract from. I want to subtract from this one, yes, using these two guys here. And now if I delete these two, you can see that, yeah, maybe this is a good entrance for my volume. Now I would isolate this volume and I would like to contour it. So contour is a command that allows us to select a solid. It should be actually, oh no, it doesn't have to be, yeah. So any type of surface or solid. And we decide the starting point and an ending point, and then we decide what is the height, for example, of our levels. Let's say I would like to have a 4 meters high levels. So it creates these polylines, actually, that I can then turn into a surface. Before turning them into a surface, I would isolate them also, and then turn them into a surface. Maybe delete the first one, and then just pick the surfaces, and by maintaining shift, the 3 surfaces, and then I click on this little button here. This little button on the gumball will allow me to extrude on the Z direction, upwards. If you cannot see this gumball or these arrows, you need to come here, down here, and activate it so it turns bluish. So right now maybe I would set 0.3 for the slabs, and right now I have my thing. So yeah, now let's analyze this. Here I have a full Slab. Great. Here I have a full slab, but what is this? Could this be beneficial for me? I don't think so. I mean, architecturally speaking. No one could sit here and watch something going downwards. There's no need for creating this half-assed circle. So probably this boolean should have been way more well thought in place and in its exact place. So these are my conditions. I need to place my spheres in spots and places that do not cause my geometry or my architecture any problems. So this is why I opened Grasshopper. So we would start generating some sort of a joystick, like a video game thing, where we can generate, we can start drawing stuff here on Rhino, and at the same time they would show us the latest volume, and then we can analyze it, just so we can focus on the optimal form, let's say. Great. So before I start using the Grasshopper, I would like to do some organization. I will go through my layers and call the first one base volume, and call the second one, let's call carving. It's like we're carving the volume, right? Volumes. So my carving volumes in this case are the spheres. So I'm going to select the spheres, maintain shift to select multiples, and click and then change object layer. And also for this one, because it's my base volume, change objects layer. And so I want to be here on the carving volumes layer. Now you see it's my current layer. That means anything I'm gonna draw gonna be on this layer. Why? Because we have this little tick in here. No worries. Let's see this later. So I open my Grasshopper, and as you know, anything we want to put in Grasshopper, so as you know, we will need to reference these geometries inside. So in order to reference any geometries, should come to the params tab and then look for the brep, which is actually short for boundary representation. Let's understand it this way. Anything with a boundary, anything that's solid or surface, can be integrated in this little library. And you can also see that it's yellowish, I mean orange, which means that it is empty, or that there is a problem. And yet this little balloon tells us that the brep failed to collect the data, which means there is no data to start with. So right now I would like to integrate this base volume here. So I right click, and then I set 1 brep, boundary representation. Turns gray, that means it has an information. I mean, I'm gonna start rushing from now on. And if you didn't see my first videos, I advise you to look at them really fast, because those are the ones with the basic information that I have to about the interface, basically. And so right now I need to call this something, so I'm gonna Control G it, Control G, then right click and call it base volume. Right, and then I'm gonna create another one, put it in a group, and call this one carving volumes. And so I can select these two, set multiple breps, and then use a boolean difference, right? Difference. I mean, it should exist, right? The thing is, in Grasshopper, it's called solid difference, not boolean difference, solid difference. So brep A is the yellow one, It's the one that's getting cut. So it's the first one is the base volume, and the carving volumes are the B. Great. So now I notice that there is something that's happening. We have overlap in geometries. Let me hide everything that I've already drawn on Rhino. And also let me deactivate the preview for this one. Turns dark and gray, which means the geometry is there, but it's not visible. Nice. And also I would do this for this one here. Preview off. You could use Control Q for it to be fast. And so what I see here is actually my geometry. And what would be interesting also is to move my geometry somewhere in the X vector. I'm gonna move it left or right, wherever. So the X factor is the unit X, and then I'm gonna choose a, let's say 30 meters. Let's move it by 30 meters, maybe a little bit more. For that I called it number slider. Remember that. And now what I could do is actually deactivate this one. As you can see, we have the first one and then the second one. So from here we can understand that Grasshopper is a non-destructive process. I mean, visual scripting, when you start connecting things, it's not a destructive process because it always keeps the geometry in its respective little components. So for example, the difference was made here and then it was moved and then it was moved. This is why we have two geometries. And for now we can just preview off this one or use Control Q on my keyboard. Then I'm gonna show back everything. And now what's cool about this is that I can start changing the placement of my spheres. And that's what I meant when I said that it's going to be some sort of a joystick. Crazy, right? Boom, damn. Anyways, I want it to be more user-friendly. Maybe I would want to add more spheres, let's say. Or maybe I'll just add a polygon. Or maybe I'll just add a curve. Voila. And then this is a closed curve, turning it into a surface by using the command planar surface. I extrude it upwards. Maybe I would want to add also this one. In this case, it's gonna be tiring. Anyways, I will need to come to the B-Rep, click, and then manage the B-Rep collection. I noticed that I already have two inside, which are the two spheres. So now I need to add another item. So I would select this one and click, voila. And now I would notice that this one also cuts. Yeah, this process is interesting, so I would like also to automate it a little bit. I'm maintaining Alt actually to drag. Yeah. So here I would like to introduce you to a new component called pipeline. What is a pipeline? A geometry pipeline. So a geometry pipeline is a listener, some sort of a listener. For example, if you give it a layer, for example, base volume, and I type it the exact way that I've written it on the layers, base volume, and here I can decide which type of geometry I want it to pick, to listen to. Points, curves, boundary representations, and the last one is meshes. Maybe we'll see that later, what a mesh is. For this one I wanted to pick every B-Rep, so I double click it. So right now if I put a panel is basically, just go back to the older videos please, if you don't know what a panel is. So right now I know that there is a geometry inside, and I would copy and paste the same thing and apply it for my second layer, which is carving volumes. And then I click OK. Now I can delete these two. And I know that my base volume is this one, and my carving volumes are these ones. So automatically, whenever I am to draw a new shape on this layer, it is going to sculpt, or it is going to sculpt the joystick volume. Let's move it a little bit farther away. Yeah, so in some sense, it mimics a little bit the process of some architects, right? And look at this little detail here. Anyways, this is nice because it actually allows me to visualize my volume. But of course, if I decide that this volume is going to be the right one for me, I'm gonna have to make sure that the floor plans are not very bizarre, right? So let me draw the floor plans. Remember the old command on Rhino? A lot of them are very similar between Rhino and Grasshopper. So the command was called contour. I'm gonna relaunch the contour command, and I'm gonna decide which shape I want to contour, which is basically this geometry, and the direction is the Z direction. Remember, my friends, the Z direction is always upwards, so I want to slice it upwards. And now let's assume a distance. My distance is going to be 4 meters. And now, since I've drawn this, I can start previewing off, and then just leaving these contours here activated. Turn them into a surface by using boundary surfaces. That's the command for it. And then extruding them, the base in the Z direction by 0.3. Great. And so now, as I have my tool, my boundary surfaces, my extrusions, I can start giving them some colors. Auto swatch, and then preview, custom preview and color swatch. This is the combo for colors, basically. Gray, deactivate what's behind. As you can see, I always deactivate everything that's behind. It's always dark gray, so I only see what I would like to see. And also now I can visualize the move geometry, which is here. Let me show you back everything here. Yeah, so it's my joystick, and now I can also change the, let's assume it's glass, bluish hue, and then change the transparency. This looks nice, also very diagrammatic. Also, I'm gonna go set view, click on this little triangle, set view, isometric NE. So right now I'm looking at my floor plans. I guess this one is fun. I mean, if you're standing here and this is your volume, I mean, this is your architecture, someone is standing here and there's a railing of some sorts, that could be interesting. Also, I just remembered that no slab, I mean, let's assume that no slab should be like really attached to the borders. Let's just offset them so they would back off a little bit. Gonna use my contours here, deactivate the custom preview, activate my contours, and then maybe offset them. Offset curve. So these are the curve to offset, and I can set my distance so to be, let's not do this for now. Let's not do this for now. Yeah, forget about it. So right now I have my volume, my floor plans. I can start playing around. I'm just gonna take Grasshopper too. Damn, that's also nice. Yeah, so now you know what a joystick is. If I add, for example, a polygon with 6 sides, turn it into a surface, and then extrude the surface and give it some weird rotation and pick it up. Okay. You know what I mean? It's actually very interesting, you know, as some kind of finding form. And remember, dear friends, your form should follow the function, or not. I finally your software tutor for today. So anyways, as I'm doing this, what I would also, some of the other things I would like to know about my architecture is actually the area. The area of my surfaces. Remember, we had the curves. We had to turn them into surfaces first, right? In order to extrude them. If I only extruded the lines, look what happens. It only extrudes the shells. So normally the basic thing to do is to create the lines, turn them into surfaces using boundary surfaces, and then extruding the surfaces. So that's one to take. And now I can use these surfaces with the command called area, which is a nice command that would find the centroid first. It would find the central point, and also it's going to find the area. I can use a panel by just typing panel, or also by double clicking and yeah, two brackets. It gives me a panel. So right now it gives me the area per meter square. I can turn it into an integer so I don't have the numbers after the comma. And now I would use a very interesting component called text. What is it? Tag, I guess. Yes, text tag. So what it does is that it takes my text, which is these integers, right? And it puts it into its respective locations. If I click on it, on the icon, I could also choose if I want a medium, large, etc, etc. I can deactivate this one, and now I know how many meters square I have on each floor plan. And from here I can start deciding if my volume is too big, if my volume is too large. Do I have enough place for my program, for example, if I'm working on a competition? I could also, you know, do this. I could do everything. And I could also, what could I do? Yeah, I could make a mass addition. So I would give it all these areas, flatten, do not forget to flatten. And then it would give me the overall surface, in meters square. Until now, I guess you understood a little bit the usage of computational design in early phases of the process, because it allows you to calculate in real time. Yeah, and also everything is automated using these geometry pipelines. I guess that would be it for today. Now, if you're still here, that means that you would love to learn Grasshopper. And for that, I would advise you to subscribe to the channel, follow us on Instagram, and also on Patreon. I'm planning to make more playful, educational content for you guys. So yeah, see you soon. Cheers.